The first 8 major element is asking question and defining problem. The first one is, does mass of an object influence motion during collision? The second one is, what are the observable effects can be seen? And the last one is, how can we measure this? The second one is developing and using model. This model, A and B, gonna show on how the same impact of force. According to Newton's third law, car B will exert an equal and opposite force on car A. This conceptual model helps us understand the expected interaction and outcomes during the collision. We have two models. The first one is car A, moving object with mass M1, and second is car B, a stationary object with mass M2. Planning and carry out the investigation. Data that we wanted to collect. First is initial position, time and final position. For the apparatus, we have toy car, roller, clay and stopwatch. Planning and carry out investigation procedure. Release car so it collides with car B, observe and record the motion on both objects upon collision, measure the initial and final position of both objects using a ruler or measuring tape, use a stopwatch to measure the time it takes for the collision to occur. This information can help calculate the velocity and acceleration of the object. Next is the precaution step. To do the experiment in a controlled environment. Next is make sure the car is in good condition. The third one is make sure the surface is smooth, and the final one is make sure the wheel mechanical is in good condition. Force exerted from car A to car B. Then the displacement of car B is noted.
Analyzing and interpreting data. From the equation P equals to mv, we realize that the manipulative variable is mass of toy cars in unit kilogram, and responding variable is velocity of toy cars in meter per second. Next is constant variable is the flat area, which is stable. Observation. Observation before collision. Car A moved towards car B, while car B remained stationary. This initial motion set the stage for the collision and the subsequent interaction between the object. During collision, car A and car B make contact, and forces are exerted between them. The interaction during the collision is characterized by the exchange of force according to the Newton's third law. After collision, both objects move in opposite direction depending on their masses. The motion after the collision reflects the outcome of the action-reaction forces and the conservation of momentum. This is our data. As you can see, for mass relationship, if a car has less mass than car B, car A is expected to rebound with a higher velocity, while car B moves slowly. Conversely, if car A has more mass than car B will move away faster, while a car A slows down and significantly. This relationship between mass and motion is consistent with the principle of momentum and force. For the force magnitude, the forces exerted by the object on each other are equal in magnitude and opposite in direction, as predicted by Newton's third law. The result validates the theoretical principle through experimental evidence and demonstrates the consistency of law with real-world observation. Using mathematics and computational thinking. For the velocity calculation, the initial and final velocity of both objects can be calculated using the measured displacement and the time data. The velocity v can be determined using the formula v equals to d divided by t, where d is the distance and t is time. For the momentum analysis, using the principle of conservation of momentum, the total momentum before and after the collision can be compared. And the momentum P is given by P equal to mv, where m is the mass and v is the velocity. The conservation of momentum principle states that the total momentum before the collision should equal to total momentum after the collision. For the force calculation, using Newton's second law, the force F exerted during the collision can be estimated by F equals to ma, where m is the mass and a is the acceleration. Acceleration can be calculated using the change in velocity over time. So to calculate acceleration, we have to using this formula, which is a equal to delta v divided by delta t, where delta v is the change in velocity and delta t is the time interval.
Moving on to the sixth element, constructing explanation and designing solution. The results of the experiment should show that the forces exerted by the objects on each other are equal in magnitude and opposite in direction, thereby confirming Newton's third law of motion. There are some ways to improve the results of the experiment, such as reduce friction. We should always ensure the surface is as smooth as possible. Then, we also repeat trials. We conduct multiple trials to average out any anomalies and improve data reliability. By implementing this solution, we can enhance the reliability and accuracy of the experimental results, providing a more robust demonstration of Newton's third law of motion. Based on the experiment, we can all relate this to a real-life car accident, which is very common. To optimize collision outcomes, engineers focus on designing collision-resistant materials and structures that minimize deformation and energy loss during impacts. For instance, the National Institute of Standards and Technology has been researching materials like nanocomposites and graphene, which show promise in resisting punctures and high-velocity impacts. Next, engaging in argument from evidence. Robustness of results. Explain how repeated trials improve measurement techniques and the use of advanced sensors can mitigate these errors. Giancoli 2006 experimental data. The motion and the final position of the objects provide direct evidence of the forces at play during collision. Obtaining, evaluating, and communication. We gather information from a variety of sources, including textbooks and online resources about Newton's third law and collision dynamics. Reviewing literature on similar experiment and theoretical models helps build a comprehensive understanding of the topic. Communicating result, present the finding through written report, a detailed report that includes all observation, calculation, and interpretation. Next is presentation, a visual presentation summarizing the key points of the experiment and the demonstration of Newton's third law. In conclusion, the experiment successfully demonstrated a simple concept of Newton's third law of motion. The observed motion of the object upon collision aligns with the principle that for every action there is an equal and opposite reaction. The data collected and analyzed provide empirical support for the theoretical prediction, confirming the validity of Newton's third law.